Hello friends, welcome to Secret of Electronics. In this video, we will learn how to make a simple CMON game using a Arduino Nano board, some LEDs and push buttons. In this circuit diagram, you can see that 4 different colored LEDs are connected to digital pins D2, D3, D4 and D5 of the Arduino Nano board through 220 ohm current limiting resistors. The 4 push switches with 10 kilo ohm pull-up resistors are connected to digital pins D6, D7, D8 and D9 of the Arduino Nano board. The 5-volt buzzer is connected to digital pin D10 of the Arduino Nano board. This Arduino program implements a CMON game where the player must memorize and repeat a sequence of LED flashes using 4 buttons. The game begins with a single LED flash and increases in complexity as the player correctly follows the sequence. The game logic revolves around generating a random sequence, displaying it to the player, waiting for correct input, and either progressing the game or triggering a game over sequence. The global variables define constants such as the number of LEDs, num_LEDs, buttons num_buttons, and the maximum sequence length, max_sequence. The LED pins and button pins arrays store the respective pin numbers for the LEDs and buttons. The buzzer pin is set to pin 10, used to generate sound feedback. The sequence array holds the LED sequence the player must follow, and sequence length keeps track of the current sequence length. The player index is used to monitor the player's progress. In the setup function, random seed analog read 0 ensures a randomized sequence each time the game starts by using noise from a unconnected analog pin. The LEDs are set as outputs, while the buttons are initialized as input_pull-up, enabling internal pull-up registers to detect button presses effectively. After a brief delay, the game starts by calling startGame function, which populates the sequence array with random values between 0 and 3, representing 4 LEDs. The main loop plays the stored sequence using playSequence function, which lights up LEDs one by one while playing corresponding buzzer tones. Tone buzzer pin 500 plus sequence I multiply by 100, 300. Each LED is turned on for 500 milliseconds, followed by a 300 millisecond of delay, ensuring a recognizable pattern for the player. After displaying the sequence, player turn function is called to monitor the player's input. It waits for button presses using wait for button press function, which continuously checks all 4 buttons using digital read function. When a button is pressed, the corresponding LED briefly lights up and a tone feedback is played. If the wrong button is pressed, button pressed not equal sequence player index, the function returns false, triggering game over function, which flashes all LEDs 3 times and plays a error tone before restarting. If the player correctly follows the sequence length increments and the game continues until reaching max_sequence, at which point win game function executes. This function flashes all LEDs 5 times with a victory tune before restarting. This program effectively combines LED control button debouncing, random sequence generation, and buzzer sound feedback to create a classic memory game, ensuring a interactive and challenging experience for the player. Now connect the Arduino Nano board to the PC using a USB cable. After connecting, open the Arduino IDE and load the code file, which you can download from the link provided in the description. Once the code file is open, select the correct board and port. After selecting the correct board and port, upload the code to the Arduino Nano board by clicking the upload button in the Arduino IDE. Now you can see the LEDs and hear the sound of the buzzer. Our game is working correctly without any issues or errors. If you liked this video, do not forget to subscribe to our YouTube channel to watch our upcoming interesting tutorials.